Sunlight beats down on the earth and passes through our bodies almost every day, but when concentrated to a single point, it can burn stuff. Same with the radio waves, they pass through our bodies, and if they're collected at one point, then they will be able to burn things. This project shown by burning some leaves and some grass with sunlight right now using a magnifying glass right here. Notice how the heat is only collected at one point and is burning at that one point.
Okay, my name is Mark Miller. I'm a student at Northview High School. I'm in 10th grade, and I want to tell you about my science fair project. My science fair project is a new novel way of approaching medicines and how to treat inoperable diseases that harm a biological system. My experiment uses radio waves, coalescing radio waves, to constructively interfere inside a biological system which non-invasively will destroy cancer cells or any other ailment inside a biological system. Every day people are dying of cancer, and I want to change that. I've even had family members die of cancer and other diseases, and I wanted to help with that. So I believe that my experiment can be used to non-invasively cure cancer. Okay, now my experiment is using multiple angles to interfere radio waves at a single point in space. At this single point, which is the center, there will be a power spike, and I will record that using this, which is a RF detector. This is an RF detector. And right now I am about to start up the circuit. So let me go down here, and this is my dad's power supply. Every circuit needs a power supply, so I need to use it to power up my circuit. This is the VCO I'm about to power up, which is a voltage controlled oscillator, which will be used as my RF emitter for today. And it says 4.98 volts, but I'm not sure, so I'm going to use my dad's digital voltmeter to record if that is actually what is being output. And it says 4.99, which is close enough to 5 volts, so I believe that number. And notice how I connected red to red and black to black. This is for ground, this is for VCC. This will be used later in the experiment. Now I have a resistor here called a potentiometer, which can be used to vary the voltages coming out of the power supply. I will connect this to the VCO first before I put on anything else. I connect red to red, green to green, let's see, right here, and yellow to yellow. Okay, now that potentiometer is connected to the RF emitter, I will now power up this emitter. Let's see, where is my detector? Right here. Okay, I'm turning it on. Right now it says it only has 12.2 millivolts per meter. So that's probably because of interfering waves coming in from the window over there. Put that down. And I will now power up this RF emitter. I connect black to green, since that's how I color coded it. And I will connect red to yellow. Okay, now this thing should be powered up. Notice how the power goes up as I put it under the emitter. 252 millivolts per meter. But when I put it in front of the antenna, the power goes down and we cannot record the experiment. So from this, I can determine that radio waves emit perpendicular to the antenna. So now, using one of our waveguides, I will insert this RF emitter, and this metal can should direct the wave into the center. Now, as I put this in at the mouth, notice how the power is amplified to 400s. And then due to wave drop off, at the center, there will be only 11.7, 12.1, 12.7. Move it around a little bit, trying to get this center. So I got around 32, 13.5. So this is only one RF emitter, and this is how it's going to be directed with all the other RF emitters. Now I've added a second VCO to the circuit, as you can see right here, and I'm going to check and see if this emitter is actually emitting power. Right now it's emitting in the 500s range, as you can see right now, 600s even. It's a pretty strong VCO. And now I'm going to see if the power had increased at the center of the table. And right now it's showing in the 20s. And, oh wow. Let's see, trying to get it focused here. 26.8 is at the center of the table. And as you can see, the power has increased at the center of the table. Now I'm going to add 3 VCOs to the circuit and see if the same outcome is present. Now I've added a third VCO to the circuit, and I'm going to check right now if it works. Again, power is emitting in the 600s, millivolts per meters. That's how it's all measured in. And now I will place this in the center again. I am all the way in the 80s, 60s, 50s with 3 in the center. Yet again, the power is increased at the center. Constructive interference. Finally, I've added a 4th VCO to the fray, to the circuit, and that's my final one, since this one is broken because it shorted out during the process. Okay, let me go check and see if this one is working. Emitting in the 600s range, 500s, 600s. So apparently that one is working. So now it's time to test and see if there was a power increase at the center. I believe so. Wow, look at that. 154, 137, 160. That is amazing. That is constructive interference. And finally, I think that proves that I can create a thermal singularity at the center, at the point, and only at that point is where the waves will add. This can be used to non-invasively penetrate cancer inside a biological system. And I believe this can be used worldwide to treat cancer and other ailments. My next step for this experiment is to see something burn. I want to see fire. I want to see something blow up. No, I was kidding. I want to see a thermal singularity actually construct in the center of the ring. And I can do that because I'm going to get a VCO that emits a higher frequency. I'm going to get a power amplifier that'll increase the amplitude so I can actually see a thermal effect to the experiment, so I can actually see something burn and have a physical proof that my experiment works. Now I think this will be a good innovation to add to the medicine field, and that's what we need in the medicine field. Change is what Obama wants, and I believe I can help him do that. And this is right now being patented as we speak. This is a patent pending. See that? Patent pending. And yes, I feel like this will work.